Now that we have that angle, all we have to do is rotate the turret to be the same angle as that vector. So this vector is now like 45 degrees. So the rotation of our turret will be 45 degrees. And as we run this imaginary arrow that we have here is going to change the angle that it is from the center, and all we want to do is just keep changing the turret. So 3 lines of code, and now we have a turret that tracks our object, our target. So what's left to do? Well, I added a little piece of code here just so people could see it that further visualizes the pointing. So what I'm doing here is every frame I'm creating a line, and then the next frame I'll delete it and replace it with a new line, and that line points from the center of our turret, and it uses the vector you'll see. Basically it says start at the turret position and then add that vector that we got up here, vector x plus my current position x, vector y plus my current position y, to prove that this does in fact create an offset that points in the direction that we want to go. So let's go ahead and flash past this. So now that's all that's left. This is all the job of the enter frame listener at this point to do, is it needs to point us in the right direction. To fire, what we're going to do is we're going to create an infinite timer. So we have a timer perform with delay every second, and then we have a closure, and inside that closure it calls shoot, which we forward declared at the top. We haven't created an object or a body for it yet, and we're going to pass in the barrel, and I'll tell you in a moment why, and end, and then -1. So basically what this is saying is every second shoot and pass in the barrel. Now the reason we're passing in the barrel is because I want to do is every time that function executes, I want to create an object here at the same position as the barrel center, and then I want to fling it off in the direction that the barrel is pointing. So let's do that together. First, let's go ahead and create the circle. Let me just steal some code here. Call it a bullet. Actually, I'm going to use temp, TMP. I use this a lot in my code because it's short to type. And we'll take the position of the turret, object X, object Y, and this is a circle call, so we'll give it a small radius of 10, so that'll make it 20 pixels wide. And let's make it red so we can see it. And we'll run it and see what it does at that point. I cannot type. We're going to run that, and boom, we got a red dot. I pause it. So there's our quote-unquote bullet. So let's do the next thing. Let's give the bullet a body, because we need to give it a body so we can use physics to start moving it. And I just realized I didn't require physics. So let me require physics. Physics. Wow. I'm so bad at typing. Okay, physics, start, physics, set gravity 0, 0. I'm going to have the gravity be 0, 0 because I don't want gravity to move our bullet. I just want it to, I want to use physics to be able to apply a force or an impulse to our bullet to move it. Okay, now let's go ahead and say physics, add body, temp, and think for a moment. We don't have to do anything else. That will apply a dynamic body to it, and I don't care about any of the other parameters. Physics, and the only thing I want is, actually I don't need to do anything else because I'm not adding bodies to any of the other objects here. Again, all I want the body for is so that I have some way to move this object other than using a transition. Physics. Now let's see if I did anything stupid and crashed the thing. Yeah, I can't type. 5. Physics. Proving once again that I cannot type. Reload. Alright, good. Okay, so again, okay, stop it. we got these bullets here. Well, it doesn't want them to overlap. So what happens there is it says, hey, this is on top of the other thing. Push it somewhere. So it pushes it in some random direction. Now we want to give it a little kick in the direction that the barrel is facing. So let's get the angle, let's get a vector representing the direction the barrel is pointing. Let's leave this here, and let's say local vec equals, we already did this once, so we'll just steal the code up here. Right here, it's going to be the same as the code previously. So now this will give us a vector that is pointing from the turret to the target, but it's got a problem. This vector is as long as this point to this point. Now, what we want to do is we want to give the projectile a certain velocity, but we want to be able to control that. So in order to do that, we have to convert this vector into what's called a unit length vector, which is sort of like the workhorse of vectors. A vector that is of unit length can be used for a number of very interesting calculations because it has this property that says it's 1 in length. So it basically represents a direction but no magnitude. The magnitude is, in a sense, how long the vector is or how much force it represents. So 1 is the magic number that you can use and convert it into whatever you need it to be. 20 pixels long, 200 pixels long. Without the unit vector, vectors would not be very useful in terms of like calculating forces, etc. So what we'll do is we'll get a unit length vector. We'll convert it into a vector of length 1, which is called normalizing. So we'll say vec equals math2d normalize vec. So I pass the vector here into math2d normalize. It does some magic, does a few calculations, and returns a new vector, which I'll just store in the same variable. And this one is pointing in the same direction as our initial vector, but now it's only 1 pixel long. So if I were to draw it, you wouldn't even be able to see it. It would just be a dot on the screen. And when I say pixel, because my calculations are in screen space, so if I were to draw it, represent it visually, it would be whatever my screen space is. So 1 or 2 pixels, whatever it's being converted to for this current scaling of the screen. Okay, so now we've got a vector that points in the direction we want to kick our bullet. So we have to decide, do we want to give it a kick, which is an impulse, or do we want to give it a fixed velocity? And I'm going to say fixed velocity because it's easier to express for this scenario, but a kick is also good. It depends on how you want to make your weapon behave. And I think that in this case, just giving it a fixed velocity is much easier to sort of grok, understand. So to do that, we need to convert this vector into a velocity vector, which says what direction is it going to move in and how fast. To do that, we say vec equals math2d scale vec, and then how long we want it to be. So let's say I want it to move at 150 pixels per second. I will simply make this vector 150 pixels in length, or the concept, again, in screen space. I'm waving my hands at the screen. I do this all the time. I wish there was a camera. You could get so much more out of this with me waving at the screen. So again, scale the vector, make it the length that I pass in here, and I always get these backwards. I can't remember I put the scale in the front or the after. Let's see. Okay, good. It's after. And it is diff self-target. Oh, look at me. I use the term object here, so I got to put that there. That's sorry. So between object and target, and let's reload it. And okay, good.